Chapter 3 Review Rational Functions. Good luck with your studying. Okay, this section is focused on rational functions of the form f at x equals ax plus b over cx plus d. In question 8, we're asked to find the horizontal asymptotes of each function. The horizontal asymptote is going to be, again, as x gets very large, but that's hard to do here because then both the top and bottom get very large. So one of the strategies we've been asked to use is to divide every term by x and see what happens. So we get x over x, and then x over x plus 5 over x. So what we have then, as x gets very large, this goes to 0, and then this goes to 1, and this goes to 1. So we end up with 1 over 1. So the horizontal asymptote for this is y equals 1. Similarly, for this one, as if we do the same thing, we get negative 2x divided by x over x divided by x minus 3 divided by x. And so I end up with, as x gets very large, again, this goes to 0. So I end up with negative 2 over 1. So the horizontal asymptote is y equals negative 2. All right, we've been asked to identify the key features for this function, x over x minus 2. We know from the bottom, right here, the x minus 2, that's going to give us our vertical asymptote. So our vertical asymptote is x equals 2. Our horizontal asymptote, we need to divide every term by x, and we end up with x over x, and minus 2 over x, and therefore this one goes to 1, as this one goes to 1 when x gets very large. This becomes a 0, so my horizontal asymptote is y equals 1. And then my x-intercept is 0, and my y-intercept is also 0, actually. Okay, looking at k at x equal to 6x plus 2 over 2x minus 1. The bottom gives us the vertical asymptote, so I'm going to write that. It's 1/2 would be the vertical asymptote. The horizontal asymptote, I'm going to divide everything by x, and then I end up with 6 over 2. So my horizontal asymptote will be 6 over 2, which is just 3. If I let x equal 0, then y equals 2 over negative 1, so 2 over negative 1, which equals negative 2. And if I let y equal 0 to find the x-intercept, I get 6x plus 2 equals 0, x equals negative 2 over 6, or negative 1/3. So that's my x-intercept. Good luck. On this page, we need to find the equation that goes with these properties: an x-intercept of 1/4, a y-intercept of negative 1/2, a vertical asymptote at x equals negative 2/3, and a horizontal asymptote of 4/3. I'm going to start over here by writing my f at x. The vertical asymptote gives me the bottom of the denominator of my function. So this should be 3x plus 2, would give me a vertical asymptote of negative 2/3. The next thing I want is my horizontal asymptote. So we know it's going to be something over 3, because 3 is the coefficient in front of here. So the horizontal asymptote is 4 over 3, so this should be a 4x. So that satisfies, we took care of the horizontal asymptote and the vertical asymptote. I want to use my y-intercept now of negative 1/2. So I know that if I put x equals 0 in here, into here, and into here, then I need to get negative 1/2 out. So the negative 1/2 would be over here. So I'd be putting x as 0 into all of the x terms, and I would have negative 1/2 on this side. So the only way to get negative 1/2 on this side is to fill this box with a negative 1. So then my final answer would be f at x equals 4x minus 1 over 3x plus 2.